We are given an equation of a curve. Okay, we see that there are two unknowns over here, a and b. X and y, they are variables. Okay, A and B are constants. The point 0, 4 lies on the curve. Whenever they give you an equation and a set of coordinates, you have to think about substituting them back inside. Here we've got x and y value. Okay, so do a mental exercise. If I sub in x equals to 0 over here, I sub in x equals to 0, I sub in y equals to 4, I will have one equation with two unknowns. The unknowns are a and b. So you have to be able to think about that. Then the next point, they tell us that the gradient of the tangent to the curve at P is -1. So we know that dy dx equals to -1 when x equals to 0. So then we will have two equations with two unknowns. And that is our approach to doing part 1. So do the substitution for a e to the power of 2 times of 0, we didn't actually have to write that, plus b e power -0 also. So our first equation that we generate is that a plus b equals to 4. Equation number 1. Second equation is after differentiating. Due to the lack of space, I'll just do it at the side. dy dx 2a e to x minus b e negative x. Do the substitution. We know that the gradient is -1 when x is equal to 0. Don't bother substituting x equal to 0 over here because I know that anything power 0 is going to be 1. So minus b. Now I've got two equations. We can make a the subject. Start to equation number 2. So solving a simultaneous equation is just very mechanical. So b value is 3. Substitute it back into our equation number 3. We have a equals to 4 minus 3, which is 1. So quite quickly, we have our values of a and b already. Evaluate, okay? So do the substitution. Okay, so integrating both sides. Integrate y with respect to x. So just copy down everything that we see with brackets, e power 2x plus 3e power -x with respect to x. Notation is important. Please don't forget to write down the dx. So here we integrate them separately. We will divide the expression e power 2x by the differentiation of the power. So when I differentiate the power, I get 2. So I divide that by 2, I get half. So here we have 3e power -x. I'm going to divide the 3 by differentiating the power of e. So when I differentiate -x, I get -1. So 3 divided by -1, I just need to change the sign. Okay, so this is after integrating. But this is an indefinite integral. We don't have any limits over here. So we need to plus an arbitrary constant c. Because I don't know what value that is. So this is the integration. Now, they want us to evaluate integrating y from 0 to 1. So I'm going to copy this down. Sorry, copy this down. E power 2x plus 3e power -x dx. So now I'm integrating this with respect to x from 0 to 1. So I know that when I integrate this, I use a square bracket. Since I've already done the integration, copy this into your square bracket. Half e 2x minus 3e -x. I can ignore the arbitrary constant already. I don't need to put in the c in here because it will cancel off. Integrate this from 0 to 1. Do your substitution and you will get the correct answer. 5SF first, then round off to 1 dp. Or rather, you can round it off to 3 dp first, then after that back to 1 dp. So 5.1, that's our final answer. Next, question 6. Okay, the logarithm question. More of you need help for this, so whoever it is, please listen. I am already at question 6, logarithm question now. Looking at the equation, log base 8 x power 3 equals log base 4 u. So the number that comes to mind when I see an 8 and I see a 4 has to be 2, because 2 power 3 is 8, 2 power 2 is 4. So we know that, got two different logarithms with different base. Probably I should consider changing them to base 2. Okay, so let's start. Part 1 for A. Using the change of base formula. Haven't done anything here yet. I've just copied down the question. Change of base. Log base 2 x cubed over log base 2 8. Not too difficult to remember. Just remember that it is a division. Whatever log base that you want on both the top and the bottom, the number that is kind of on top goes into the numerator. The number at the bottom, which is the base, goes to the bottom. So that's how I remember it. So we do the same for the other side. Log base 2, whatever base you want, the number that is on top, that's our u, divided by base 2 again, the number that is at the bottom, which in this case will be 4. Now you should be happy to see things like log base 2 8, as well as log base 2 4. Because as mentioned, we can change the 8 to become 2 power 3. So doing so will result in log base 2 2 power 3. And you should be happy to see this, because log base 2 2 is 1. Now this 3 over here, we can bring it down, and it becomes 3 times log base 2 2. 3 times log base 2 2 is 3 times 1, which is just 3. Okay, so on the other side, doing the same thing, log base 2 u over log base 2 2 squared. Due to a lack of space, I'll just continue on this side. Log base 2 x cubed over 3 log base 2 u over 4. 2. They want to express u in terms of x, meaning make u the subject. Okay, so we have log base 2 u equals to 2/3 of, bring down the power 3, log base 2 x. So now I've got both of them log base 2. That makes my job a lot easier already. And the 3's can be divided. So log base 2u is the same as 2 log base 2x. We want to do a direct comparison, and I think it's quite possible for us to have just log base 2u equals to log base 2 something else. Okay, right now it is 2 log base 2x. We only can get rid of this 2. We can bring it back to the power, give it to the power for x. Log base 2 x squared. Now we can really do a direct comparison. U has to be equal to x squared, because both of them are log base 2. Log base 2u equals log base 2 x squared, therefore u must be equal to x squared. Okay, so here is our answer for part 1. Now find the value of x for which log base 4, okay, we've got a quadratic inside, x squared plus 5x minus log 8 x cubed equals to log 1 over log base 3 4. This is part 1 and part 2. Usually, they are related. Part 1 and part 2 should be related. But it didn't say hence. So you don't have to use the answer in part 1. But if you were to try and find a relationship between part 1 and part 2, what do you notice? Okay, everybody please look at this question first. Look up, pause whatever you're doing. I'm giving a hint. Part 1 and part 2 are related. Usually they are related, okay? Although they didn't say hence, try and find a relationship between them. Can I use anything from part 1 to help myself in part 2? What is the similarity? Log 8 x cubed. You see it over here? They are the same, right? So that means I can use whatever I found in part 1, u equals to x squared, and I can do a substitution over here. Probably that will make my work easier. Probably, I don't know. But since it was already done, I'm going to give it a shot. Okay? First, I'm going to make log base 8 x cubed the subject. Okay, so if you are able to do part 2 already, you can continue with your work. Thus, if you're interested to see how this works, just continue. So from the second equation in part 2, we have log base 8 x cubed, making it the subject. Log base 4 x squared plus 5x minus 1 over log base 3 4. Okay, so here again we have two different bases. I've got a log base 4, I've got a log base 3. We cannot just subtract them straight away. We need to make sure they have the same base. Would you like to change the base to base 3 or base 4? You should recognize that this can very easily be converted to become, I'll use another color for this. This is actually the same as log base 4 3. We just change the positions and you remove and you take the reciprocal. So instead of 1 over log base 3 4, it becomes log base 4 3. That is also very easy to remember. So when I have a log base 4 and a log base 4 with a subtraction, then it's easy also for me to evaluate. On the right hand side, I have log base 4. Since it is a subtraction, I'll be doing a division. X squared plus 5x over 3. So this is the right hand side of my equation. The left hand side, instead of using log base 8x cubed, hey, since we've already found out log base 8x cubed is the same as log base 4, u, but instead of writing u, we found out in part 1 that u is x squared. We should use that. So we have just done a substitution. And see, log base 4 of something equals log base 4 of another expression. Therefore, the two expressions must be the same. X squared has to be equal to x squared plus 5x over 3. Now this is a quadratic equation. I'm sure you can solve it. 3x squared minus x squared minus 5x equals to 0. Two x squared minus 5x equals to 0. Factorize 2x minus 5 equals to 0. X equals to 0 or 5 over 2. So I have two solutions over here. But can both of them be accepted? Do I need to reject one of them? This is something in A Maths that needs to be done frequently. All your answers, you need to keep checking whether both of them are acceptable or not. Same goes for our modulus. Modulus, trigo, logarithms, our exponentials. When you have a solution, when you have the final answer, don't be too happy yet. Check by substituting whether they make sense or not. So when x is equal to 0, we have log base 4 0 square plus 0 minus log base 8, 0 cube. Is this possible? If you can't remember, your calculator, just log base anything 0. So log base 10, 0. Oh, it's an error. So I know that, although I didn't memorize it, I know that log base whatever, I cannot take log base anything 0. Doesn't work. Go and look at your graph for your logarithms. It never touches the axis. So x equals to 0 must be retracted. So the other value will be x equals to 2.5. And that will be, we have no issues with that. Next, 6b. Solve the equation e power y times e power y minus 2 is 15. Can you recognize that this is quadratic? E power y minus 2 is 15. So do the expansion. We have e power y and we square this because it's multiplied to itself. Minus 2 times of e power y minus 15 equals to 0. If you are able to work with this, good. If you need to do a substitution to help yourself see better, go ahead. Let e power y be equal to, for example, x. So we have x squared minus 2x minus 15 equals to 0. Do your factorization if possible, otherwise use your quadratic formula. X, 5 and 3. So we have x minus 5 and x plus 3 equals to 0. Therefore, x must be equal to negative 3 or x equals to 5. Substitute it back. E power y equals to negative 3 or e power y equals to 5. Is it possible for a positive number? E has a value, E has a value. It is a positive number. Is it possible for a positive number to the power of anything to result in negative? Not possible. So this is rejected. Over here, e power y equals to 5. Since the unknown is in a power, I need to either compare bases, which in this case you definitely cannot change 5 to base e, or you take logarithms on both sides. The most convenient logarithm base will be e. So we have y ln e equals to ln 5. Y equals to ln 5. This is the exact value. Okay, then we can evaluate it with our calculator. Show the 5SF. 1.609. So round it off, 1.61. Question 7. Find the value of a and b for which a quadratic is a factor of this expression with a power 4. Can you tell which topic this is? The word factor should give you a clue. So this is our remainder factor theorem. But we have learned from our remainder factor theorem that when x plus 1 is a factor of px, for example, then p, when you substitute negative 1, it will be equal to 0. That's our factor theorem. But we have always been dealing with linear. The power of this factor is always 1. Then we know, if for example x minus 3 is a factor, then I need to substitute x equals to 3. But here we have quadratic. How are we going to do that? So the approach is that if, for example, 6 is a factor of, say, 72. If 6 is a factor of 72, then the factors of 6, where 6 is equal to 2 times 3. 2 will be a factor of 72. Okay, this is how factors work. If 6 is a factor of 72, then 2 will be a factor of 72, because 2 is a factor of 6. Similarly, then 3 will be a factor of 72. So from here we can tell that this quadratic factor, 2x squared plus 3x minus x, since it is a factor, if I can factorize this quadratic expression into 2 linear factors, then each of the linear factor will also be a factor of this polynomial with a power 4. So we're going to use this approach. First step, let us factorize 2x squared plus 3x minus 2. So it has to be a 2 and a 1. Let's put a 2 over here and a 1. 4x and x. If I want a positive 3, put a negative over here. So we have 2x minus 1 times x plus 2. So now I have 2 linear factors for this quadratic expression. They tell us to find the values of a and of b over here. There are 2 unknowns. All the x, they are variables. Now if I were to do my factor theorem, I substitute x equals to half, I will end up with one equation with unknown a and unknown b. Of course, after you substitute x equals to half, it will be equal to 0. There's one equation with 2 unknowns. I need another equation. So the other equation has to come from the other linear factor. Substitute x equals to negative 2. So presentation wise, since we are going to be doing all this substitution, I think it is convenient for us to let fx be equals to this. Okay, but you copy this down in your answer space. So let fx be equal to that. We know that when we substitute half, we will get 0. So 2 half power 4, 3 half, 3 plus a. Actually, we can start evaluating. 1/4 plus half plus b. This is equal to 0. That is equation number 1. So from this equation, I have one unknown a, one unknown b as expected. Substitute x equals to negative 2 next. So negative 2 power 4 will be 16. Negative 2 power 3, negative 8. 4 plus b equals to 0. Okay, equation number 2. 2 equations, 2 unknown, go and solve. Arrive at a equals to negative 6 and b equals to 4. Concept wise, there isn't anything much, and that earns you 6 marks. Using the values of a and b, solve. So let's do the substitution for a and of b. In part 2, this is our equation that we need to solve. To solve an equation with a power 4, we need to separate it into its factors. Just like when we solve quadratic, we try and find the factors, let it be equal to 0, and then we can get the values of x from the individual brackets very quickly. So here, power 4, we expect up to 4 brackets, up to. So here we need to find the factors, and we don't have to go, we don't have to start from scratch, because they already told us that 2x squared plus 3x minus 2 is a factor. So from here, we know that this, if we let px be equals to this, then I can rewrite px to be 2x squared plus 3x minus 2. This is quadratic, so I expect 2 more brackets over here, each linear, or we can expect another quadratic in this bracket. It is safer to leave it as quadratic because not every quadratic can be factorized into 2 linear. Maybe you will end up with a quadratic with roots that are not integers, where you have to square root. So it's better to leave it as quadratic. Now, how do we find out this quadratic expression? You can either do your long division. We divide our 2x power 4 plus 3x cubed, 2x squared plus 3x minus 2. Tiring. Okay, but it gets the job done. Or we can do comparison. Since I know that my px, the highest power of x is 4, and we've got a x squared over here, in this bracket, in the other factor, it must also be quadratic. The general expression for quadratic will be ax squared plus bx plus c. This is the general expression for quadratic. The general expression for linear will be ax plus b. Then for cubic, ax cubed plus bx squared plus cx plus d. So now we want to do a comparison. In order to get x power 4, it can only come from the multiplication of 2 terms. 2x squared, 2x squared and ax squared. This is the only way I can get x power 4. So from here, we tell straight away that a equals to 1. We don't even need to do the working. Okay, the next easiest one will be the constant term. The constant term is 4. The only way I'm going to get a constant over here is if I take negative 2 multiplied by c. So negative 2c must be equal to 4, c must be negative 2. Left with one last unknown, which is b. There are many ways you can do it. Can be creative about it, but one of the most straightforward is if you just substitute in values. Okay, let x be equals to, for example, 1. When you let x be equal to 1, our polynomial becomes 2 times 1 plus 3 minus 6 plus 4. Okay, that's after I substitute 1 inside, and it has to be equal to this expression at the bottom. 2 plus 3 minus 2, open bracket, a I know it is 1 already, 1 times 1 square is 1, plus b times 1 is b, minus 2. So solve this. 5 minus 6, negative 1, negative 7, plus 4, negative 3. 5 minus 2 is 3. Here we have 1 minus 2 is negative 1, plus b. Divided by 3 on both sides, negative 1, plus b. Now b equals 0. Oh yeah, b equals 0. Okay, so now our quadratic is actually 2x squared plus 3x minus 2. Instead of a, we now write, oh, we don't need to write. a value of 1, so you put x squared. B's value is 0, C is negative 2, x squared minus 2. And this is supposed to be equal to 0. We have already factorized the first quadratic at the start of part 1.
So where is all the marks?
Where are all the marks?
Yeah, 6 marks, then where, like, 3 marks.
Oh, 6 marks is for part 1. Okay, then this one is only 3 marks. So we have already factorized this in part 1. Then now we only need to solve this. X squared minus 2 equals 0. X must be plus minus square root 2. And that's our 4 values of x. Question 8. The question on modulus. Oh wait, modulus is part 2 and part 3. Okay, so for part 1, the curve and the line do not intersect. When they talk about intersection, they are talking about simultaneous equation. Whether they intersect or not, they are still talking about simultaneous equations. However, when they say they do not intersect, it means that the simultaneous equations have no solution. And when we talk about no solution, either two straight lines are parallel, or the discriminant of the quadratic that is in our syllabus is less than 0, is negative. So these are the only 2 cases that we know. So since we have a curve and a straight line, we are definitely not talking about parallel lines where they don't meet, therefore no solution. We're going to be talking about the discriminant being less than 0. So if this, yep. What?
Like the first scenario, you said two parallel lines.
Mm-hmm.
I don't remember any question from that system.
Maybe because it's too basic. 2 parallel lines, they never meet, they won't have solution. For example, y equals to 3x and y equals to 3x plus 1. So these 2 lines, they are parallel. Because the gradients are the same, they are both 3's. If I were to solve them, simultaneous equation 1 and 2, I get 3x equals to 3x plus 1. Sorry for the handwriting. 3x equals 3x plus 1, and I get 0 equals to 1. That doesn't make sense. There is no solution. So parallel lines, if you try and solve them, if you try and solve simultaneous equations of parallel lines, you will end up with problems like this. 0 equals to 1, 10 equals to 7, negative 1 equals to 3. They don't make sense. There is no solution. Because they don't intersect. So when we are dealing with this, a curve and a straight line, let's call this equation number 1 and call this equation number 2. Solving equation 1 and 2 simultaneously, we end up with 2x minus x squared equals to mx plus 1. Try and solve this. We change it to the form that we are comfortable with. Ax squared plus bx plus c equals to 0. That's how we solve quadratic equations if we do not know whether they can be factorized or not. X squared plus mx minus 2x plus 1 is 0. Group your x terms together. So now I've written in the form ax squared plus bx plus c equals to 0. Discriminant b squared minus 4ac. We are going to give it a value, or rather a range of values, based on the fact that they do not intersect. Since they do not intersect, discriminant is less than 0.
So can put that in.
What?
Can put the less than 0 in.
This less than 0? Yeah, you can put it at the end. That means you want to evaluate it, you want to try and simplify this first.
Yeah, that's good.
Okay, can be done. So we are going to expand the square over here. We have m square minus 4m plus 4 and minus 4. M square minus 4m. Less than 0. Okay, yes. We can factorize an m out. So m minus 4. This is less than 0. along our m axis. We're dealing with m squares over here, so this is our m axis. This is a parabola opening upwards. It is going to intersect at 2 points. They are 0 and 4. I want my quadratic. I want the quadratic to be less than 0. Which part of the graph is less than 0?
0 to 4.
This part. When I say it is less than 0, I'm referring to the y value, the vertical axis value. This region over here is greater than 0. This region is also greater than 0. The region that is less than 0 is what I've shaded between 0 to 4. So this tells me that my m is going to be from 0 to 4, not inclusive of 0 and 4. This is how we always solve our quadratic inequalities for our syllabus. So this is the set of values for m. Now part 2. Sketching the modulus curve is the same as sketching a curve without the modulus, but we just flip whatever is below the x-axis upwards. That's all. So our objective now is to sketch y equals to 2x minus x squared. I know it's going to be a parabola opening downwards because the coefficient of x squared is negative. It's going to have this shape. And I also need the x and y axis as well as the turning point. These are the points of interest that we must always show. So to find the y-intercept, when x equals to 0, y equals to 0 also. When y equals to 0, we know one of the solution. Now I'm trying to find the x-intercept. So I set y to be equals to 0. You end up with 2x minus x squared equals to 0. So you factorize. 2 minus x equals to 0. X will be 0, no surprise, because that is our y-intercept, or x equals to 2. So we know that it will cut at these points. Now since the x-intercepts are 0 and 2, we know that the midpoint will tell us where the line of symmetry is. So far I have a parabola opening downwards. It intersects at 0 and 2. It must be symmetrical. So the line of symmetry will be x equals to 1. The maximum point must be at x equals to 1. Substitute x equals to 1. Y will be equals to 2 minus 1, which is 1. So these are the coordinates of the maximum point. Next, since I want the modulus, whatever is below the x-axis, whatever is below the x-axis, we reflect it upwards.
So what's the actual name of the next line of symmetry?
X equals to 1 is known as the line of symmetry.
Right now symmetry equals 2. I mean equals 1.
No, you write down line of symmetry is x equals to 1. But they didn't ask for the line of symmetry, right?
No, I just want to know how to do it.
Oh, okay. So here, we are almost done, but you need to erase whatever is below the x-axis. So here I have my graph of y equals to modulus 2x minus x squared. Then we are ready to do part 3. Okay, if we extend our graph, because they didn't give the range, so we can feel free to extend it more. Find the number of solutions. Modulus 2x minus x squared equals to mx plus 1. Number of solutions will be number of intersecting points, number of intersections. We already have our graph of 2x minus x squared with a modulus drawn. So next, I need to draw the graph of mx plus 1, and this has to be equal to y, because our graph is y equals to 2x minus x squared modulus. So the same y equals to mx plus 1. Draw the graph of mx plus 1. That's what we need to do. In part A, y equals to m, which is 1, x plus 1. Y equals to x plus 1. I know it's going to be a straight line. It is going to slope up. It is going to intersect the y-axis at 1. This is the same 1 over here. It is going to slope up, passing through this point. A line sloping up that passes through this point has to look like this, right? Do you think it will cut this portion of the curve? You can take a ruler, you try to angle it. There's no way you will meet this center part of the quadratic curve. Take a ruler, go and angle it. The only time when you will touch the middle portion is if your line is horizontal, but that must mean that the gradient equals to 0, which is not the case over here. It is a positive gradient of 1. So it has to look like this. Whether you draw it this way, or if you didn't draw it accurately, you make it steeper, or you make it very, very steep. It doesn't matter. Because we are looking for the number of intersection points. So quite clearly, there is definitely one point over here. If we were to extend this, will it cut again? Yes. Even if you make your line very steep, your gradient, your quadratic curve will also keep extending up and it will cut again. You have to be able to visualize there are two intersection points. Okay? So for part A, 2 is the number of solutions. Next, the case of m equals to negative half. For part B, sketch the graph of y equals to negative half x plus 1. Again, it is going to cut with the cut the y-axis at 1. But the gradient is negative half over here. So I know it is going to slope down. It is going to slope down through this point over here. So take a ruler. If it slopes down this way, how many intersection points do you see? If it slopes down this way, we see 1 on the left side, 1 on the right side. 2 points. But is this the only possibility? If I were to slope down this way, can you see that there are still 2 intersection points? If I extend my parabola this side, it will still cut one time here and cut one time here, isn't it? So as long as I change the steepness of the graph in this direction, there will be 2 solutions. But what if I go the other way? Is there a possibility of 3 solutions? Yes, when it touches this point, there will be 3 solutions over here. If I were to continue, do you see 4 solutions now? So we need to identify another point for us to be able to determine the number of solutions. A convenient point for us to choose is therefore this x value of 2. When x equals to 2, I want to see where my straight line is. When x equals to 2, y equals to negative half times 2 plus 1. That's 0. Right? When x equals to 2, y equals to 0. I know the other point is here. My straight line, therefore, will pass through these 2 points. And here I see that 1, 2, 3. For part B, we've got 3 solutions. So the gradient over here is going to affect the number of times it cuts the line. The last question. Don't be afraid of your using our OR formula. So the issue over here is to find the horizontal distance O to B in terms of theta. That's not difficult. If this is theta, I need the opposite, and I've got a hypotenuse. Opposite hypotenuse. Oh, sine theta equals to OB over tan. OB is tan sine theta. Look at what they ask you to show. It is already given, tan sine theta. So if they want the horizontal distance of C from the vertical wire OY, so that's what I've indicated over here, then our 24 cosine theta must refer to this distance. We can use this as a hint. So apparently this has to be 24 cosine theta. This is a right angle. Where exactly is theta? So we have to determine where theta is. If theta is given over here, this is a right angle triangle, this must be 90 minus theta. If this is 90 degrees minus theta, this is 90 degrees, and all these three angles are on a straight line, then this must be equal to theta, because they must all add up to 180 degrees. So let's call this unknown x first. Let's call it z. So 90 degrees minus theta plus 90 degrees plus z must be equal to 180 degrees, adjacent angles on a straight line. So make z the subject. We have theta. Okay, so we have proven that this is the same angle theta. So to find the horizontal distance using a right angle triangle and the hypotenuse is given 24 cm, cosine adjacent, that is our unknown, ADJ over 24. Adjacent equals to 24 cosine theta. And that was what they asked us to show. So add them up, get the answer. Express y in the form. So here, whether or not you are able to do part 1, part 2, use your R formula. Square the coefficients, add them up, square root it, that's our R. Tangent inverse, since they want cosine, put your cosine in front. So this is 24 cosine theta plus tan sine theta. So alpha equals to tangent inverse tan over 24. But because this is a cosine, then there will be a change in sign. Yep, there will be a change in sign over here. For a moment I forgot. So this is cosine, 24 cosine theta plus, then we will change this to a minus. So just do the substitution, and we will end up with, for our answer for part 2, L equals to 26 cosine of theta minus 22.620 degrees. Part 3. To find the greatest possible value of L. L, we see that it is dependent on the coefficient of the cosine. It is 26 times something. But that's a constant. Our variable is theta. As theta changes, theta minus 22.62 changes. As the angle changes, cosine of the value changes. But I want the greatest possible value of L. So I want this to be as big as possible. And we know that the greatest possible value of cosine is actually 1. So the greatest L is 26 times 1, which is 26. And then include the units. They also want the angle when it happens. So cosine equals to 1 is either at 0 degrees or 360 degrees. So we have theta equals to 22.620 degrees or 360 plus 22.620 degrees. We have to select one answer. According to the diagram, theta is an acute angle. So this is rejected. round it off, 22.6 degrees. Okay, then for part 4, I'm not going to go through it because it's just solving a trivial equation.